Okay, so this is going to be the derivative of arcsine or the inverse of sine function. And so on the left side over here, I wrote arcsine of x is equal to y. And since these are inverses, I can also say that sine of y is equal to x. Okay, so the reason I can do that is inherently because they're inverses. And you'll notice if you say sine of arcsine of x, right, I'm just substituting this y right here and putting it here. Since that's equal to arcsine of x and I substitute that in, I will just get sine of arcsine of x equals x, which is a property of inverse functions. Okay, so moving forward, what I'm going to do is I'm going to take the derivative of this, and I do that over here in step 1. So I just wrote d over dx sine of y is equal to d over dx of x. And it's just kind of me writing the notation. And then step 2, um, you use the chain rule here and you take the derivative of sine, which is cosine, of y, and then you do the interior function, which is y. So that's just going to be dy over dx, right? It'd be the derivative of y, which can just be reset as dy over dx. And then, of course, the derivative of x itself is going to be 1. So cosine of y times the dy over dx is equal to 1. And what we want to do is we want to isolate dy over dx. So I divide both sides by cosine of y. And you see that here in step 3, where I have dy over dx is equal to 1 over cosine of y. But we want this in terms of x. So I draw your attention over here, where I wrote the Pythagorean identity for trigonometric functions. And what we're going to do with this is we are going to isolate um, cosine squared of y first. So we're just going to have cosine squared of y equals 1 minus sine squared of y. And then we're just going to take the derivative of both sides. Or not the derivative, we're going to take the square root of both sides. And we'll just be left with cosine of y equals the square root of 1 minus sine squared of y. And then with that said, we can input this square root of 1 minus sine squared of y to replace this cosine of y. And you see I did that over here in step 4. Except that's not exactly in terms of x yet. So I look back over here. Sine of y equals x, right? Well, what we had over here is sine squared of y. And essentially all that is sine of y times sine of y. So I can just say that's x times x, and I end up with x squared. So I can write this finally as dy over dx is equal to 1 over the square root of 1 minus x squared. And an important thing to note is look where this function is defined. So you'll notice when x is 1 or -1, it's undefined. And anything where x is greater than 1 or greater than, or well, less than -1, any time that the absolute value of x exceeds 1, it will be undefined because it will end up being negative over here, and you can't take a square root of a negative for obvious reasons. But yeah, so that's interesting because if you look at the actual graph of arcsine, you'll see that it's kind of, I can draw a little representation. But you'll see it's kind of looks kind of like this, and you have your axes kind of intersecting right here. As it approaches this point here, we have two vertical tangents, and these two vertical tangents have the values here of 1, or this is -1, and over here we have 1. And so you'll kind of see that here because a vertical tangent is undefined, right? So when we have the derivative of 1 over 0, we know that there is a vertical tangent there, or something of the sort, right? So that checks out. And then anything past that, it won't be defined, because if we were to have this sine of y, sine of x reflected across the axis right here, the y equals x axis, this would go on forever, right? Because it is a periodic sinusoidal function. Of course, we can't though, because if it did, then it would start coming back down and doing this again, and then it would no longer be a function. That's why they cut it off there, and that's why it's only defined between this interval of -1 and 1, and it has these peak values here, where basically you plug in your sine value, the value that you got, and it gives you back your angle, hence the inverse, rather than plugging in an angle and getting out your value for that angle. So that's basically it for taking the derivative of arcsine. It's not very complicated. You just needed implicit differentiation, the chain rule, and just some basic trigonometric derivative knowledge, some identities, but that's about it.